Hello, guys. I got something really exciting for you today. I'm going to show you how to use DESMOS, the calculator that you will have when you take the SAT. It's the built-in calculator. Okay, so I'm going to share my screen here, and we're going to look at test, digital test number one. So if you haven't taken this test yet, and you just want to take it as a diagnostic, you may want to skip the session until after you've taken the test. If you've already taken it or you don't care, that's fine. We're going to go through some questions from this particular test. So, which expression is equivalent to x squared plus 3x minus 40? Okay. So, there's a couple ways we can solve this, right? Um, and the easiest way to do it is factoring, but let's just look at what happens with this calculator. Pretty cool calculator here. So if I put in X, all right, and I go down here, I have the square, okay, square feature, 3x minus 40. Aha. Now I can look, and here I can shrink this down here. I can hide the calculator here. And I can move this around wherever I need to. And where I want to move it is obviously to where I can see the expression here. I could see where exactly the parabola crosses the lines. Now, if I can't see exactly where it crosses, guess what? Do you see what I just did? I just clicked it and I see the x-intercepts, also known as the zeros. So this is telling me that it's crossing at -8 and at 5. Those are my x coordinates for where the parabola crosses the x-axis. So what does that mean? If it's -8, then I'm looking for +8 here, and I'm looking for a -5. So let's see, what have I got here? -5, +8. So B is my answer. X minus 5 and X plus 8 is going to give me that the equation I want here. So that's how we can solve this really quickly. Okay, here we are on number 8 here. So this is not necessarily how I would solve these problems, but I'm just going to show you how you can use a calculator for this. Notice we still have the parabola from the last problem up here. So I want to click on here on the bottom right here, and I want to click on that X. It gets rid of our parabola. Now I can put in this equation. Now I still have to put it in. What is the positive solution to the given equation? I need to put this into um, a different form where it's just not going to work. So when I work it out, okay, the form I'm going to end up putting it in is x squared plus 6x minus 55. Okay, and I do not want to put in my equals 0. Okay, I don't want to put that in there. I just want to leave it like this. Okay, and notice as we're building it, the equation, the graph was building itself in the background. So I click on enter here and I reduce this so I can see. And now again, I see where it crosses the x-axis. Can't tell exactly where it is. So I want to click on here and it tells me that 5 is the coordinate. 5 is the x coordinate. So there's my answer, 5. Okay. And that's how we get it. Now let's look at number 10. There's another one here that's pretty interesting. If the given function g is graphed in the xy plane where y equals g of x, what is the y-intercept of the graph? Okay, so let's try this one. Let's get rid of that. And let's put in, so that's going to be y equals 11. So y equals 11. I've got 1 over 12 there. Um, and let's see. I don't want to click the parentheses. I want to click this on the outside here, and I want to click this here. Now it automatically puts in, well, I should have clicked this one. That's right. I should have clicked this one, and then I can put in whatever I want. So I want to put an X there. Okay. Um, Now, what does this do? Okay, so let me click here and reduce this here. And there's going to be a y-intercept, obviously. I can't tell exactly where it is. So let me click on here, and then it tells me it's at 11. So my y-intercept is at 0, 11. Boom. There's my answer. So, and this calculator comes on the test. You can actually use it on the test. So let's go to number 14 here, see how we could use it here. And how many points do the graphs of the equations, these two equations intersect in the XY plane? Okay, now, if these have the same slope, so I shouldn't really need to graph this. Okay, I shouldn't. I should be able to look at this and say, okay, well, there are two different lines, two different slopes. Um, so obviously they're going to cross one time. Okay, boom. But let's complicate it a little bit. Let's turn one of these into a parabola, and let's make it a little trickier. So let's say y equals negative x squared minus 2x plus 20. Okay, and let's make the other equation y equals 8x. So y equals 8x. And let's see where they cross, how many times they cross here. So, boom, I'm crossing here, and I'm going to cross, I'm going to have to cross again, and it's going to be way down here. So let me click that again, and cross it right down there, and it actually tells me where I cross. So I cross twice when I have this. Most of the time you have a parabola and a line, you're going to cross twice. Um, so that's just obvious. But again, it's obviously going to cross once here too. But this is the way you could graph these. And if I were to graph the lines, it would just show the one place where they intersect. Let's look at number 18. So there's a lot of these we can do with this calculator. 18. Okay, this is a fun one here. Solution to the given system of equations is blank. What is the value of y? I'm just looking for y. What can I just copy and paste? No, I can't. Got to put it in. So I'm just going to put in just like it is. 6x plus 7y equals 28. 2x plus 2y equals 10. Click my enter. This, where do they intersect? It's hard to tell. So let me click on one of these, and it shows me the intersection is at 5, 0. No, it's at 7, -2. That's where the intersection is. 7, -2 right here. If I can't see that very well, if I'm not really sure about it, I can make it zoom in here and click it again. There it is, 7, -2. So what is the value of y? It's -2. There's my answer. Boom. Let's look at number 20 here. The given equation defines the function f. For what value of x does f of x reach its minimum? Minimum, okay? So let's go here, get rid of these, and let's just put in, I'm not even going to put in the y equals or f of x equals. I'm just going to put in the quadratic part here. Just be lazy and see it still populates. So I can look here. Where is my minimum? Okay, I can go here. And again, just click on here and it tells me my minimum. I'm looking for the value of X. The value of X here is 6.25. It's 6.25. There's my answer. Boom. Magic. Okay. Awesome stuff. Let's take a look at 14 in the next module. Okay, we've got let me click on our calculator here. We've got the graph. This graph has an x-intercept of a0 and a y-intercept of 0b, where a and b are constants. What is the value of b over a? So we need to find out b over a. And there's a way that you can do this, okay? That's not too difficult, but we're just going to do it the easy way and plug it into the calculator and hit enter here. We actually don't need to hit enter. Let's look at where our intercepts are. So if I click on here, my x-intercept is 4.429 and my b-intercept, negative, by the way, and my b-intercept is going to be, click over here, my y-intercept, I'm sorry, it's going to be minus 15.5. Okay, so those are some pretty nasty little numbers there, but we can put b over a, and here's all we need to know. 15.5 is obviously greater than, where did my y-intercept go? Oh, I'm sorry, my x-intercept, lost it here for a second, is obviously greater than 4.429. So if I'm looking at these as our answer choices, then I know that first of all, I've got a negative over a negative, so this has to be positive, and I've got a larger number over a smaller number, so that my answer is going to have to be 7 over 2. Okay, and that's it. So those are just some of the many uses of DESMOS calculator. Pretty awesome calculator. Play around with it, start using it, practice with it, and see what you can do to solve these equations and get these answers a lot quicker. All right, see you next time.